Hello and welcome to this session on a day in the life of Rapido's data scientist. And I have with me Siddharth Panchanathan. I am really excited to welcome you, Siddharth.
Thank you. I'm grateful for the opportunity to be here and talk to so many people about, what we do, not just at Rapido, but what do data scientists do, what it takes to be successful as a data scientist, and what kind of skills and abilities are important to be successful.
Great. Before we talk about Rapido itself, I know you've had an interesting journey. So you've studied operations research and computer science at Cornell University. You have worked in the US, you have worked in India, you've worked in algorithmic trading. So maybe let's start with that. Can you tell us a little bit about what was going on in your life before you got into data science?
For sure. So, like you mentioned, I studied operations research and computer science. And my specialization was in financial engineering. So when it came time to graduate, one of the fields I was looking to get into was quantitative research and algorithmic trading. And I say this having had no experience during like an internship in algorithmic trading. It just seemed interesting, seemed like an interesting intersection of, maths, statistics, and computer science. So I decided to give it a shot. And given like my specialization in financial engineering, it seemed like a good fit. Managed to get a job in the US, did that for a couple of years there before I decided to move back to India to be closer to family. Continued my journey in quant trading here in India as well for a couple of years before I decided to make the jump into more core data science. My personal reasons for that were I felt that algorithmic trading and quantitative research is a more closed off community when it comes to sharing research and sharing new developments and ideas. And I felt like I wasn't learning as much. Not to say that you don't learn in quant trading as well. There's a lot to learn and learn about like the markets and statistics and how they are applied to make money. But I felt like I wasn't learning as much about new methods, and all of us here, given that we are interested in data science, know how quickly changing the industry is and how new methods and technologies come out like every day, every month. And I felt disconnected from that rapid growth, and hence I decided to sort of switch into core data science, which is what I've been doing at Rapido for almost 3 years now.
Great. And I just want to learn a little more about that transition process, because this is a question that a lot of people have, that if you have been working in a particular domain for a few years, often it feels like this is where the rest of your career is heading, but you decided to then make a transition. So what was that? What went into that transition, and what was that process like for you?
So that's a great question. One of the things that really helped me take that leap into core data science was the fact that I felt like I had a good base in statistics, maths, and programming. So, I mean, data science is not something magical, or it's not like this black box that you need to have a specialized education for. And this is something we'll touch upon in the later part of this conversation as well. Just being passionate about solving a problem is what a data scientist needs, I think, more often than not for any other skills. So it was like a lot of the skill set translated, statistical research, being able to make sense of numbers at a large scale. A lot of these skills translated quite linearly. So that sort of gave me the confidence to, try something else out. And yeah, I went through the interview process and managed to like get a job. So yeah, I've not looked back since then.
Great. Yeah. And you joined Rapido almost close to 2 years and 9 months ago. And
Yeah.
why Rapido? What got you excited about Rapido at that point?
That's a great question again. So I'm based out of Bangalore. So people who are based out of Bangalore know how bad the traffic can get. And I was a daily user of Rapido, particularly for almost a year before I joined the company. So having used the product almost 2-3 times daily, like I understood the product they were building. I sort of I liked that they were building something for India. It was not just, okay, take an idea that's manufactured elsewhere and repackage it and repurpose it for India. It was something unique. It was something that, I saw had a strong future for, our country, and we are progressing as a nation. So given that I could see like holes in the product that I felt like I could help fix, not fix. I felt like it was a good place to be. It was good because like I knew the product, I understood the customer aspect of it, and I felt like I could take some of that and help fix things from like the back end and the marketplace side of things.
Great. And Rapido, especially in the last 2.5 years, has grown so tremendously. And I also just want to add my own appreciation of the app. I have literally like 4 or 5 apps on my phone, and one of them is Rapido, and that's the app that I use 3 or 4 times a day, no matter where I'm going. And I know that we've reached a point where you cannot trust any other application with reliably getting you from one place to another within a certain set of time. So it's an amazing app. It is, and the company or the platform as a whole has scaled really, really well to continue to become better over time. And I think we would love to hear a little bit of the inside story as well. How have the 3 years at Rapido been, just in general, and also in from the perspective of data and the kind of projects you've been working on?
For sure, like you mentioned, Rapido, the scale of the product has grown immensely year on year since inception. We grew almost 4x 5x since when I joined, and this obviously includes like a brutal period during the pandemic where we weren't able to operate at the scale that we wanted. But yeah, it's a testament to the entire organization for staying committed to their vision for building for India, and never sort of compromising on quality of product thought and quality of analysis, and taking the right bets. So that definitely helped us stay grounded, having like a clear vision, like even through like multiple lockdowns and unlocks, our vision did not change. And sure, I mean, we went through like a few pivots, every organization does, but our underlying belief and like doing the right thing, trusting the numbers, trusting analysis, giving engineering and operations teams like all the help that they need to grow and build a product that can really operate at scales that we operate at. Yeah, it's been like a great journey, and really proud to be a part of like an organization that so many people use on a day-to-day basis. And specifically from the data side, as companies grow and scale, the value of data gets more and more magnified, because you are now having to make decisions that are worth millions of dollars, and all you have to go by is like your data and your gut feeling. So finding that right balance between figuring out, okay, this is where we want to invest, and these are the metrics we want to look at to double down on our investment, and being able to support the organization, and that has been really rewarding.
Great. I would love to understand a little bit about what a day in the life, or maybe a couple of weeks in the life of the data scientist or the data science team look like. So can you give us some insight into that?
For sure. So, at any organization, and this is true for, companies that are both small, for all small, mid, and large size, data scientists and data science teams, they have to play a pretty multifaceted role. It's not about just looking at numbers, or like looking at Python notebooks, or looking at SQL queries, or building machine learning models. To operate as a successfully operate as a data science team, you have to take into consideration a lot of things. So just going into like what a typical 2-week period looks like, you have organizational goals that have been set and have been sort of assigned to like particular teams. So one of the big things is like aligning these high level plans and goals of the organization and breaking them up into smaller discrete tasks that can be executed by the data science and data analysis and data engineering teams. Because a lot of times all you're given is, like, okay, you need to achieve this, and that you need to work backwards from that into like, okay, like to achieve that, I'm going to do like A, B, C, D over like the next 5 to 10 days. And this is obviously like the timelines, they vary project to project, like you sometimes have to do this like discretization over a 3-month period. Sometimes it's just a 1-week period, but being able to provide that clarity of thought to those working with and under you is really important to like the efficacy of what we do as data scientists as well. Apart from this, obviously designing and deploying experiments, understanding, okay, like what is it that I want to do by through this experiment? Do I have all the relevant measuring tools for this? Do I need to build a data set? Making sure all that is in play. After that, obviously, like analyzing said experiments, you've put in all this effort, you've designed a great experiment, you need to make sure it's running well, you need to make sure it's not breaking anything in production. You need to be constantly liaising with, business and operational stakeholders, and, making sure that everyone knows what you're doing and why you're doing it and how it's going to impact their bottom line. Because as organizations scale, you have different people who are responsible for different metrics, and often data science projects, they cut across a lot of these verticals, and it's up to a data scientist to effectively communicate what they're doing and have a buy-in of like all the stakeholders whose bottom line is going to get affected at the end of the day. Apart from that, our data scientist plays a very crucial role in liaising between teams and product teams when it comes to new feature design, when it comes to data set enrichment, when it comes to building data products. Having the ability to think 2-3 weeks, 1 month, 2 months down the line, being able to foresee how a product is going to evolve is really important for engineering teams and product and design teams to sort of do their jobs properly. If I, as a data scientist, don't know how this experiment is going to like lead to a product change or what it's going to require me to build as a iterative improvement, you're just adding a lot of inefficiencies down the line. So making sure you understand how all of this is going to, roll back into the product, roll back into the app, roll back into the experience, not just like immediately, but in the near future, is really important. So you have to spend a lot of time, thinking about that as well. And again, like data science teams data scientists can operate in silos also. You have individual contributors and you have people that work with larger teams. So obviously, as an individual contributor, you're going to be spending like a decent amount of time in whatever, coding environment is of your preference. Usually at this scale, it's usually Python or R or Spark that most people like work with. So you're usually just working with a lot of data, trying to figure out what it is that you need to get out of this data set and what kind of like insight do you need to like provide back to the organization so that they can use that information to take decisions successfully. And yeah, I mean, all of this rolls up into, like documenting all the things that you have learned, all the things that you have found, all the future experiments that are going to, come as a part of like your previous learnings. And like I earlier mentioned, like making sure like everything is crystal clear across like all teams, and this rolling up into, like everyone's plans sort of converging at like your desired end state over like, like 2 to 3 months, which is usually the time frame with which we operate for our goals.
Right. I think one thing that a lot of people don't really understand or appreciate is that data scientists have to bring so many people together, so many teams together, the leadership, the product, the engineering. Then you have like maybe several other functions, operations, and you have to keep every single thing in mind. And you have to deal with all of these issues of like invalid data and data that is sometimes older, formats changing, data entry issues. So how does one stay sane in that kind of with so many variables in play?
It definitely gets overwhelming at times, like I don't think I claim to, have it perfected. There are weeks where like I feel like it's all too much, and like having to do all this is a bit taxing. But you get used to it, like you're sort of you're chasing that thrill of, building something that actually works and works demonstrably well. That this is just something that you learn to live with, and you get better at it with experience. You start like figuring out these things earlier and earlier, so that you can sort of split your time and account for all these things, account for people just being on leave,
Right.
account for like a long weekend or like 5-6 days of holidays coming up. And I think like majority of it is just being effective at communication. Most of the times, like all these misinterpretations, they come only if like you're not communicating to like your stakeholder ki, like, okay, I'm not going to be able to do this because XYZ. People are usually very understanding, and they're happy to like give you that extra room or extra time. So yeah, it's just a combination of you experience and effective communication.
Great, great. Thanks. Well, I know that you have something interesting prepared for us. Just for the rest of for everybody watching, well, you have seen how you book a ride on Rapido and immediately you get a captain and he's never more than 3 or 4 minutes away and he's always on time and everything goes smoothly. We are now going to see how it goes from the other side, everything that Rapido does to make sure that captains get interesting or rights that they're likely to accept and that they show up in time. So the dispatch mechanism. I know, Siddharth, you have something around that. I'm also really excited to learn more about it. So I'll maybe allow you to just share your screen and let you talk about it for some time.
Okay, awesome. Cool. Like Akash mentioned, you know, going to try and walk you guys through, like a really important and interesting problem that we try and, solve with data. It's the problem itself may seem like pretty straightforward from like a app product experience point of view, but it's actually really important to our entire dispatch mechanism. So I'm going to sort of, talk through what does it actually mean to solve a problem with data, and what are all the steps that are involved in solving a problem with data, and like how you should sort of go about doing it in a sane and sensible and practical manner. So yeah, let's get started. So this is a very this is a very common problem in the ride sharing space. You will find similar case studies done by like multiple organizations such as Uber, Lyft, Ola, Didi, and whatnot. It all depends on, like the kind of use case you're solving for. So for those people who have not used Rapido or are not familiar with ride sharing apps, the way it works is, as a customer, you're sitting somewhere, you want to go somewhere. You type in your pickup and drop locations, and you're shown a price, and you request a ride. And like as everyone knows, like that request is sent to like all the drivers nearby in your nearby area, and it's up to them whether they want to accept it or reject it, or like do the ride and basically drop you to where you want to go. So what does it actually, what do the drivers see? Like when you're sending them an order from a customer, like what does it do they see on their app, right? So this is sort of what our driver slash partner app looks like when they are receiving an order, right? So it's a very simple problem statement, right? What exactly do I show the driver to convince him to accept more rides and drop more rides? For people, so as you can see, I have two iterations of an order acceptance screen. That's what we call this. I have two iterations of it, one on the left, one on the right. On the left, you can see sort of some set of information shown here, you have some information shown here, right? You have what type of ride is it? It's a bike taxi ride. Here you're showing the additional fare, a component that the driver would get for doing a ride at this time. So let's say this ride is happening at night. So the driver gets an extra 12 rupees to, accept and drop this ride. You see what is the payment method. This is how the customer pays. Like customers can pay in cash or they can pay through online methods such as the inbuilt wallet or credit card or UPI. And the driver can see where the customer needs to be picked up from, right? And how far away is the customer from the captain or driver at that point. And looking at all this information, the driver can choose to either accept the ride or skip it, right? If he accepts it, he's showing some intent to, wanting to do this ride. If he skips it, pretty much he's telling you that he's not interested, right? So you have iteration 1 here, you have iteration 2 here. Iteration 2 is slightly different from iteration 1. Here we are showing the overall earnings that the driver gets for this. And that's sort of split up into like the base fare and like the additional component. Some of you can think of this as like a surge pricing for, doing a ride at night times. Another difference that you see here is not only is the customer's pickup location seen, but the customer's drop location is also visible, right? So I'm sure a lot of you can sort of already put the pieces together to see where we're going. I'm sure a lot of you guys, especially those based in India, are more than familiar with the behavior of drivers to call up the customers, ask them where they're going, and basis what the customer says, they may choose to like continue with it or then cancel the ride, which obviously sucks. It sucks for everyone. It sucks for the customer. It sucks for the driver. It sucks for the platforms because you have wasted everyone's time at the end of the day. So our goal is to, figure out which of these screens would actually lead to a better experience for everyone, not just the customer, but also the driver. Because at the end of the day, a driver is just as essential as a customer is. That's the whole point of a two-sided marketplace. We are simply the platform that brings the two together. We cannot say that I care more about one group over the other, because if one goes away, the other does not exist. So yeah, that's the problem statement at a high level. Which of these two screens should I show the driver to get him to have a better experience, to get him to accept more rides, to get him to drop more rides, right? So you're a data scientist, you have been given this problem. Before you jump into like, ideation and, figuring out which statistical test to use or what is the distribution of your drivers at a particular time and place, you have to think about the problem. You have to understand like what is it that is being asked of you, why is it being asked, and what value can you add to this whole process, right? So one of the things to start off with, and I mean, there's no right or wrong way of doing this. This is just how we sort of deal with this problem statement. So this, and like a lot of times, like there probably like have been past experiments that have been run to see has on order accept screens to see if like has there been any. As a data scientist, like the first thing you should do is when you've been presented with a new problem is understand, has anything been done on this already before? Because if there has been, that is an additional source of signal or learning that you can take to sort of say, okay, like we have tried this in the past, I'm not going to try this in the future. So start off with seeing if any past experiments have been conducted, look at the outcomes there, see what happened when let's say showing the drop location, did it help or did it not help, right? Get an understanding of the user base which is going to get impacted, right? Like in this case, like the impacted user is primarily our drivers. So having some prior understanding, and this comes from talking to other people within the organization. If you're a user of the product, you talk to drivers yourself, talk to your operations teams to see if there's any research being done about like what kind of earnings do drivers want to see, like do they want to see the surge price included or not included, if yes, why or why not, like this is basically like, think of all this as like, your data gathering phase. Like I said, if your organization has a UX research team, like, spend some time with them, like see if they've, done any research on this in the past. Like I said, if you're a user of the product yourself, try and talk to your end user. If you're taking a ride, you can ask your driver, ki, like, why do you accept or not accept a certain ride? Was it because I didn't show you where I was going, or because I didn't show you how much you were going to earn on this ride? These are all just things to like establish a good prior in your own mind before going into like developing something as a hypothesis, because having a good prior is just as important as like the entire experiment itself, and not having a good prior is pretty counterproductive. Similarly, from an engineering point of view, like, understand, is there any issue? Like, one of the things that like is really India centric is, like, a lot of the logistics partners and drivers, they may not have like a super big screen on their phone. A lot of these guys have just very simple smartphones with not super high resolution screens, not super fast processors and whatnot. So, just something as simple as, hey, on certain models of my phone, like, a lot of this information gets like hidden because of the resolution of the screen. So, like, understanding from an engineering perspective, hey, like, we need to fix this from like an engineering and backend point of view before we even try this experiment. Otherwise, it's just going to be a waste of time and money doing this. So again, it's all about like having good priors, making sure like from every point of view, from like an understanding, from an execution point of view, what is currently going on, and this helps ki the change you're about to make, is it worthwhile or not. So coming to like, building a hypothesis building needs to always have like a very practical approach. I keep telling people this, like, you don't have to always do the most complex mathematical thing to, build a hypothesis or try and validate your hypothesis. Like I said earlier, like, it's a common complaint from customers across all ride sharing platforms about, drivers who, after accepting a ride, they tend to call you or they message you and ask you, okay, like, where are you going? And basis their own preferences, they may say yes or no. And that's really frustrating for a customer, because you feel like he has accepted the ride, so it's his duty to sort of, fulfill it. But in reality, that's not the case. There's no constraint on him to do that, and it's really hard to enforce such a constraint as a marketplace as well, because our fundamental USP is that drivers can come to earn, customers can come to get rides. And they are not full-time employees. We don't treat them as such. We don't want them to be full-time employees, because we want them to just come, earn how much they want, leave if they want to. Right? So coming to the problem at hand, like, one simple solution to this, it's easy to say, like, hey, why not just show the drop location? Like, what's the harm? Like, that would just make things really simple. But that is not the case. Like, you have to ask yourself that question: would showing drop location uniformly actually increase rides at a macro level? Like, is that really going to help you in the long run? It may come off as like an easy publicity when you can put a post on LinkedIn and Instagram saying, hey, we're doing this for our drivers and whatnot. But from a business, is that actually sustainable for you? Like, you need to that as a contingency, right? You have to plan for unexpected outcomes. Just off the top of the bat, you have to assume that, like, there is a certain subset of your population that accepts rides not knowing what the drop location is. And then once they've accepted, they sort of feel obligated to do it, right? Like, there's nothing wrong in that. There exists a segment of, those drivers in our marketplace. They exist in every ride sharing marketplace, where once they accept, just because of who they are as people, they want to complete the ride. Right now, showing drop location uniformly might tie into their own preferences of where they want to go. So you have to plan for it. You can't like run the experiment and then, be surprised and have like a shocked face. And then when your acceptance is down like 5-10% and you're having to justify this. On the other hand, having thought about it before and talking about it to all the stakeholders and saying, what, like, this is a possibility. I feel like this could happen. Getting that buy-in from everyone beforehand just makes things easier for you, because in the end of the day, you're responsible for like the bottom line of a city or a particular division, and you don't want to like mess things up for them too much. There could be safety issues, like showing drop locations for female customers at night can be considered a safety issue. You don't want to find yourself in an unfortunate situation where there's a clear gap in your product, and this is something that customers can really prod you about. So again, not saying it will be a problem or is even a problem, but you just have to think about it. You have to be ready for certain unexpected outcomes. Coming to like the more data science and statistics part of this, experiments are as good as the success metric that they are trying to move. If you're unclear about like what you want to achieve by doing something, it's just a massive waste of time. I mean, I'm not saying it's always a massive waste of time, but as you get to more specialized experiments and you get to a more mature product, each experiment has like a real impact on like real people and also the business. So having a really well-defined success metric is absolutely essential. This is non-negotiable for any data science experiment, right? So in the context of this, what is it that we want to do? Do we just want to increase the drivers accepting the orders? No, that is not what we want to do. Like, we want them to accept the orders and then drop the customers as well, because accepting orders is just part of the game, right? Like, if the driver is accepting and then going to the customer and saying, you know what, hey, cancel this and just pay me directly, that doesn't help us as a platform. It's not ideal for us, it's not ideal for the customer. Like, there's a lot of safety issues. You can't track the customer, you can't track the location. And once you get your destination, if your driver says, you know what, you cancel the ride, pay me 50 rupees more, or pay me like x amount more, customer has no way of like pointing to something and saying, hey, you know what, but you only should be charging me this much, right? What we actually want to increase is, like, let's say, the full funnel from like the driver accepting, the driver arriving to your location, to actually dropping you, right? Another alternative is obviously increasing overall rides, which only happens if this entire funnel moves in the right direction. Like I said, basis what you want to achieve, your experiment design needs to change slightly. If you just want to increase acceptance, it's really easy to like just make like a really intuitive like order accept screen, show everything to the driver and improve acceptance that way. But you're going to like have drop-offs in other parts of the funnel if you don't like think about all the potential misfires, and you're not having a successful, like a well-defined success metric. Coming to the actual experiment design itself, right? Let's say you've answered all these questions, you know everything that could go wrong, you know what you want to change. Now it's time for you to actually do the task that is the actual bread and butter of a data scientist, which is designing experiments and getting learnings, right? So what does this usually entail? So obviously, you need to have a preliminary hypothesis about this change is going to impact different segments of end users and customers and marketplace conditions, right? Like, is by making this change, let's say, like, if you go back to those two screens that I showed you, like one on the left had some information, one on the right had a lot more information, right? So you need to have more detailed, more granular hypothesis about who actually this is going to impact. Is it going to impact my full-time drivers? Is it going to impact my part-time drivers? Is it going to work better in my peak periods, like in the mornings and evenings where there's a high volume of rides? And showing that additional information just helps the drivers make a better decision for themselves and for the customers as well, and hence leads to like a better growth of your rides. Is it going to work better on the weekends? Again, because routes on the weekends may be better defined in terms of customer going from point A to point B, having like a better correlation on the weekends. And obviously, like, another thing that is really important for any experiment to succeed is having like well-defined like test and control, splitting techniques. For you to analyze the impact of a change, where you're making a change, you usually almost always have to have a group which you're not making any change in, and both groups need to have like really similar characteristics. So this brings you to like a problem that almost every data scientist is going to face, like if not like with each experiment, like at least once every like month or every 2 months. Like how do you randomly split a population effectively, right? Like it all depends on like the population that you're going to impact and your understanding of that population. Like I said, like segmenting your end user, like is it your full timers, your part timers, is it your weekday drivers, your weekend drivers, when do you want to run the experiment, who is it going to impact, right? What characteristics do I want to keep similar in my tests and control groups? Like if you're running experiment on acceptance via the order accept screen, you obviously want like your test and control groups to have similar prior acceptance ratios. You want to make sure that both groups are receiving similar amount of orders. If you have one group receiving 1,000 orders, whereas another group only receiving 10 orders, like that becomes unfair comparison. I mean, it's not even unfair, it's an invalid comparison because your scales are so different that like aggregations and like benefits from the aggregations, they start appearing, and you are doing disservice to the actual signal, which is, did my change actually like improve something in my overall funnel? If you as the data scientist say, you know what, I didn't think about this, and like now I'm sort of dealing with it later, that's just bad form. And I mean, it's just going to waste everyone's time, because now you have to figure out like alternate techniques to like deal with unequal groups, right? Like like another thing that is relevant in the context of Rapido's order accept screen experiments, like do I want them to have similar earnings per hour, which is like, do I want to make sure that as a prior that they have like equal opportunity in the marketplace? Like I said, do they need to have similar acceptance rates and whatnot? So another thing with a splitting technique is you should have it vetted before the experiment actually goes into production. If you're doing something like, okay, like I'm going to split my test and control groups basis, like whether the unique ID of the driver ends in either an odd or an even digit, right? It's a pretty simple, straightforward technique, and at scale, it gives you really good splits because it's really random. But a simple check for a data scientist would be, okay, like before launching the experiment, if I were to actually create two splits like this over, let's say, 10,000 drivers, the two splits that I do create, are they similar across these metrics that I want them to be similar across? Because if they're not, everything downstream becomes tougher. Like if I have splitting technique A and I get two groups from that, group one and group two, if I see that group one and group two have like very different acceptance rates already, then it will be that much harder for me to attribute any goodness coming from my change in the experiment, just because their prior distributions are already so different, right? So if this is something you catch before you launch an experiment, you can change your splitting technique, you can change the target metric you want to be similar across both. You can use like complex techniques such as cosine similarity to make sure like a vector of metrics remains similar across both groups as much as possible. All of this just makes your own life really easy in the future. Otherwise, you're going to be dealing with, okay, you know what, before one group had a mean of 40, one had a group mean of 60, but now after the experiment, one has gone to 43, other has gone to 67. Unequal basis, unequal comparisons, you're going to be sitting and trying to figure out like, okay, did this actually work or not? When you're the person who should be accounting for like all these things. Another thing that is, really, overlooked in a lot of, in a traditional view of what a data scientist does, you just assume that, all this beautiful, clean data is going to exist for you to like analyze. That is almost never the case. You need to be in touch with like your data engineering team, your data sets team, to make sure, like, okay, I'm going to make this change. Do I have all the support from you guys to make sure that like I am able to like actually attribute the experiment? Like forget attribution. Am I even able to like analyze the data, right? So I was able to split well. But if I didn't keep the data engineers in the loop to tag each driver as whether was he part of the test group or was he part of the control group, I'm lost, because now I made this change. I have no idea like how to track it. I have no idea how to say, okay, this guy saw what, this guy saw what, right? Do I need a new data set? Like, do I need to, because the way customer apps, all applications work is like you have a person taking an action on the application. It doesn't just magically go into like a CSV file for you to track. There is a, industry standard for how these events are usually like inflowing into our system. They usually go into like a Kafka queue, and then the Kafka queue reads into like a, like a data store, and the data store then like exposes that via something like Metabase or Tableau for like a data scientist to consume at the end of the day, right? So I need to make sure that whatever change I'm making is able to like, I'm able to like actually access that data. If I need to create a new data set, I need to tell my data engineering team to sort of, track this new event. I need to make sure it's flowing into my data platform correctly. Or even if it's better, like if an existing data set can help me figure this out, great. If I need to create a new data set, I need to like tell people. Otherwise, you would have wasted 1 week running an experiment and then realize at the end, like, I don't have, I don't have the data I need. Right? Keeping all stakeholders in the loop. I spoke about this earlier. Like there in larger organizations, you have multiple teams running multiple experiments. It's not like everyone is like stop doing everything they're doing just for you to run this one, order acceptance experiment. Like if I'm running this experiment in, let's say, Bangalore or Delhi, and I don't tell the local operations team, like they are not going to like magically, come to know that I'm doing this. So not keeping stakeholders in the loop can introduce what we call confounding variables. Like you don't want the city team or any other team to do something that is going to interfere with your experiment. Like in our case, like we are trying to figure out through UX elements what improves acceptance and completion rates, right? But just because I didn't tell the city teams or I didn't tell a relevant stakeholder, they could be doing something completely counterintuitive, counterproductive to your experiment. Like if some city team is running an offer of extra 25 rupees to every driver who signed up in the last like 2 weeks, sure, like a lot more people are going to be accepting now. Because of this, like your target metric, which is acceptance rate or completion rate, is going to get skewed because you have like a confounding variable outside your experiment which is impacting your target variable. And because of this, your experiment is pretty much invalid, all because I did not keep my stakeholder in the loop. And because of this, I now need to figure out, okay, like this guy's got an additional 25 rupees, this guy did not. I have to come up with like a complex sampling technique to make sure, again, like even though I had a good splitting technique, I have to now subsample my like test and control to make sure, okay, now I still have a clean test and control, because again, everything comes downstream from you having a solid test and control, because that is what is going to help you attribute. Right? Now that the experiment is done, you've done all this hard work, you've done all this heavy lifting, you've enabled your experiment, you have the data flowing in. It's been a week, it's been 10 days, 2 weeks, whatever. And now, your boss is asking you, your manager, your stakeholder, finance guy is asking you, did the changes work? Like, are we able to like accept and complete more rides? Like, did it actually work? This is where, like having like a good base in maths and statistics is like really important, because this is where you start looking at numbers and you have to take learnings from these numbers. Right? So if you're going to compare acceptance rates between two groups, right, it's a very simplistic view of like what needs to get done. Like, okay, did one group have a higher acceptance rate than the other, right? But how do you know that they're different? You can just say, okay, like show me the average acceptance ratio here, average acceptance ratio here, like are they different? And this is what most statisticians and data scientists call a hypothesis test. You're basically trying to see, okay, of two groups, one where I made a change, one where I did not make a change, like are the two, because after I made the change, are the distributions significantly different, right? And for you to like effectively run a hypothesis test, you need to understand how your data is distributed. Is it normally distributed? Is it exponentially distributed? Are they like categorical variables that you're measuring? Like, so to even run something like, significance test and get a p-value, you need to understand like how your data is distributed. Like if it's normally distributed, great. If it's normally distributed and it's numerical, great, use a t-test. If it's sort of a time series data, work with a z-score. If it's categorical, use a chi-square test of similarity. This is where like more domain specific knowledge is really important. And I would say that there's a lot of great sources to learn about this, Jovian being one of them themselves. So this is where like having like a good base in statistics and maths really helps, right? Again, while you're analyzing, being practical is key. You are not here to write a research paper. You are not here to like prove the existence of a new element. You're not chasing behind Six Sigma statistical significance, right? Like it's not like you have to prove the existence of like a new element of matter, like a boson or something. Statistical significance is purely an indicative paradigm. It just helps you take a decision. It helps you interpret whatever you're seeing, right? Like it's not the end all and be all of any experiment, right? What does it even mean for a p-value to be less than 0.05? I mean, a p-value inherently is just telling you like whatever difference you're observing in the means between two groups, like how random is it that you're observing this, like a p-value to be less than 0.05. What it actually means is like, okay, there's less than a 5% chance that this happened randomly, and there's like a 95% chance that this happened because of what you did, right? But again, this is just indicative. If like you have a statistically significant p-value, but you're not seeing any difference in your target metrics, then what is the point? Like we have had successful experiments with a p-value greater than 0.05, and we have had unsuccessful experiments with a p-value of less than 0.01. Right? It all matters. You have to approach these constructs in the context of your organization, your use case, the scale at which the experiment was conducted, and like how much breathing room do you have. Like working with just 25 data points, like if you get a p-value of less than 0.01, it may be like less important than having a base of 50,000 and having a p-value of 0.06. Like it's about like looking at the larger picture. Don't chase behind statistical significance just because like that's what is the right thing to do. And at the end of the day, like I can do all this like fancy maths and like go say p-value 0.01, but like if my stakeholder says, "Ki boss, did my net rides grow or not? Did the number of instances where drivers accepted and dropped the rides, did that change?" If you say no, it didn't change, but I have like a statistically significant experimental results with like a mean difference of like 0.25% increase in like driver acceptance rates, they're just going to be like, what's the point? Like we are not going to invest in like all the tech and all the time and all the planning to like run more of these feature changes when you're just showing me this much of a difference. And again, like p-value and magnitude of difference in delta are not the same. Like just because the magnitude is small doesn't mean the p-value is going to be large, or just because the magnitude is large doesn't mean you're going to have a really small p-value. So it's all about like it's going back to having that target metric in mind, and finally everything boils down to that. If that moved enough, provably, then you're good. Then I mean, sure, it helps to have a statistically significant difference of means there, but again, it depends. You have to look at like other extraneous factors, like did it rain, like did something else happen, was there like a big event that like messed up my demand and supply? So yeah, just having like a good understanding of like what all can go wrong even in the post experiment analysis period is really helpful. You have to be logical about your outcomes, obviously. Like when it comes to getting learnings from experiments, it's not enough to say, okay, what I did worked. You have to go that extra mile and sort of, and this is like where data scientists and data teams in general add value, right? Like being able to explain like, who did this actually help, right? When you're working at the scale of companies like Rapido, and like there are some companies that existed even larger scale, like companies like Google, Facebook, LinkedIn, and whatnot. Like there, even minute changes, like it is attracting certain people and it is like detracting certain people. So from a business point of view, you have to understand like who's this actually helping. Like by showing drop location on my order accept screen, what segment of my drivers did this actually help? Like if there is a segment where this did not work at all, why should I waste my time like continuing to show these guys this information that they clearly don't care about? Right? I want to be tactical about how I'm deploying changes on my app, because every time I change something, the experience also changes, and like there are broader retention and funnel level implications for like large experiential changes. So you want to extract maximal value from like, like as relevant a group as possible. You don't want to be doing this with a heavy hand. So in the context of this, like by showing drop location, if you like, can you learn what kind of drop locations are preferred? Are people trying to go to high demand places? Are people just trying to go back to where they live? Are they trying to get to a particular place at a particular time? If yes, why? If no, why not? So yeah, successful experiments have metric movement as well as explainability. Something changed. Why did something change? Like without answering this, why did something change? Like you're going to be fighting a very uphill battle to scale whatever you've built. Because at the end of the day, everyone wants to know like, okay, like you made this change. Why should I do this for everyone? Why can't I only do it for like one part of my population and then not have to spend as much? Like a lot of these, rollouts have a financial cost. Like if you're one of your experiments is, I'm going to give an additional amount to get an order accepted. You can't infinitely scale it because there are cash burn implications. But if you can figure out, okay, I need to only do this for my drivers who are about to churn, or my drivers who have just onboarded onto the platform, then that's a more tactical deployment of your resources, and you will get away with like spending way lesser than you would if you just did it for everyone. This is something that again I'd like to focus a lot on. Like 2 out of 10 experiments we run are successful or conclusive. That's just the reality of being a data scientist. That's the reality of being a researcher in any field, be it like a scientific researcher, be someone who's working at a startup like I am, or doing like proper graduate or PhD level research. Like you have to try a lot of things for something to work. Like not everything is going to work. Like so this is coming to like talking about cases where it doesn't work. Usually like there's 1,000 different things to try. So knowing something is not working is just as valuable as knowing something is, because even unsuccessful experiments can often circle back into product improvements. Specifically, I mean, even in our context, like knowing what not to do has led to about 50% of like what you see on our app today. Like what you see on our app today is like hundreds of failed experiments that have told us ki like, okay, you know what, definitely don't do that, because it really does not work. And in the context of like our order accept screen itself, like we went through like this whole set of like very, very detailed experiments, taking up a lot of like product design and analysis time, only for us to finally realize after doing all these experiments that just because our accept screen was in English, it was really not intuitive to like almost 60-70% of our driver base, given that India is a very lingually diverse country, and different regions prefer to speak different languages, and a lot of drivers prefer seeing information in their local language. So this is just an example of us like spending almost 3-4 months like trying to like increase acceptance to our order accept screens, only for us to realize that half the times these guys don't understand what is even on the screen. So like we tried XYZ, like we saw random metric movement, only for us to do like an extensive research project to understand none of this even matters unless you like start translating what you write on your screen into the language that drivers would like to see. So like it's not about getting disheartened just because an experiment didn't work, or you didn't see it go to prod or see it go into the app. Our job is to add value, and if you're adding value by telling people what not to do, that is the same as like adding value by telling people what to do, because in the end time is a constraint, money is a constraint, and there is infinite of neither. So yeah, I mean, I try to keep it brief. Hope that was informative, hope that was helpful.
Thanks a lot, Siddharth. Wow, that was really revealing just to see how much thought and how much consideration goes into just something as somebody might think something as straightforward as a driver, as a ride acceptance screen, right? There's so many parts to it and so many variables you have to consider. All right, I think, well, there are a few questions. I was able to pick up some technical questions that people were posting during this presentation. So I'm going to maybe talk about a few. The first one was about the success metric. So the success metric that you have, is that a business metric or is that a technical metric? How do you decide what is the right success metric?
Again, that's a great question. So it all depends on like the team that you're in and what is the objective of your team. The team I am a part of in Rapido, which is the marketplace dispatch team, like almost all our success metrics are eventually business metrics, because that is what people understand. Like it's really hard for me to go and say, like I created this new technical metric and I'm going to move this. In the end, our goal is to help the company grow, help the company do more rides. So in the context of our business and our team, like all our success metrics are 99% of the time business metrics, because that is what we have to move. That is not always the case. Like different teams have different success metrics. Like you may have a data scientist working on like a data engineering team whose entire success metric is purely technical. So you can't, there's no one size fit all answer for that. But in my context, yeah, like most of our success metrics, business metrics such as fulfillment or rides per day or cash burned per ride and all that stuff.
Got it. And another related question here is about the sample sets that you create for A/B testing. The question is, are they homogeneous? And if not, then what do you do about that?
Sorry, I lost you for a second there. So I
No
heard,
problem.
are they homogeneous? And what was after that?
Yeah. And so are they homogeneous? And technically, I mean, in the ideal scenario, they're supposed to be, but what do you do if you're not able to ensure homogeneity or have provably homogeneous sample sets?
Yeah, so the answer to the question is no, they are not always homogeneous. You just have to sort of deal with it. Like if you have two groups that you have designated as test and control, and you see that, okay, what, afterwards the homogeneity does not persist, then often what we have to do is we have to subsample those groups to get that homogeneity, which is why we usually run experiments at scales where we account for this. If you're running just 100 users in your test and control group, then if the homogeneity diverges after the experiment, you're sort of shit out of luck, because you don't have enough numbers to like subsample that and still have enough volume to say, okay, like, okay, I went from 100 to 25. These 225 are homogeneous, but is it enough to just look at 25 users to say it worked or not? So we try and run experiments at scale where we know that, like it's impossible to say that two groups will be homogeneous in perpetuity. So we use scale to our advantage to sort of run experiments at scales where we know we can subsample if needs be.
Got it. All right. One more question. Has identifying the distribution of the various aspects of the data set, the various features in the data set, does that help in any way when you're designing the algorithm, when you're kind of figuring out what kind of tests to use?
Yeah, for sure. I mean, not in the context of this one particularly, but, let's say for our machine learning models that we do deploy, and this is something that I think most people here will be aware of, like understanding your data and like doing that EDA and looking how variables are correlated with each other, how they exist just as their own, like a single variable. Like, do you want to look at it as a time series? Do you want to look at it as like you want to look at it as a pair plot? Like, I mean, it depends, right? Like, so for complex models, you need to have a really good understanding of, okay, what features are you working with and why they should persist. Why should you even consider them in your model for training? So yeah, I mean, the answer to that is definitely yes. Not understanding your distribution is just going to make things harder for you in the future. Like you don't want to you don't want to do something assuming a data set is normally distributed, because a lot of statistical methods and algorithms assume normality. Normality is a prerequisite. And then if you're giving a non-normal data set to that, and you're just saying, okay, my I'm XYZ inference basis on non-normal data set, but a normal statistical method, it's wrong. It's not correct, and you don't want to do that, and you don't want to get called out on it by someone else as well.
Yeah. All right. Well, there were also a lot of questions throughout the presentation about the data science as a career. So maybe
Yeah.
that is something that I want to talk a little bit about. What advice would you have for today's data science aspirants, for everybody who's on this call and people who are going to be watching this?
Sure, for sure. I'll try and keep this, like brief. The number one thing is build a solid base in mathematics and statistics. While being well-rounded, as a thinker is important, you need to be a good communicator. You need to be able to express yourself clearly. In the end of the day, as a data scientist, people are coming to you for your expertise in numbers and research, right? They'll find someone else to communicate the problem well to the management, but in the end, they are relying on you to make sense of numbers, large chunks of data, and make sure that they're not going astray, right? So that's number one. Number two, for people who are either already data scientists or not even data scientists, always read blogs. I'm not even saying read research papers or read technical books. There is a lot of really great data science teams across established companies such as Airbnb, GoCheck, Uber, LinkedIn, and a lot of these organizations, they publish blogs about how their teams work, how they run experiments, how the data pipelines look like, how the experimentation platforms are designed. And even as someone who's in the industry, I learn so much just by seeing what other people do, because some organizations have scale and expertise at levels that even we don't have. And it really helps to say, okay, these guys are solving something like this, this is how you deal with confounding variables. This is how you deal with really shitty data. So constantly being in the loop as to what the industry leaders are doing in terms of product related data science is really helpful, and highly recommend the blogs of product based companies that do publish stuff on Medium or towards data science, or their own websites. A lot of stuff like Uber and Airbnb, you can go on their website and they'll have blogs on how they run experiments and what they found, and really cool visualization techniques and whatnot. Next thing is to be clear in your thought and communication. Again, this is not something like anyone, sadly can teach you in a book. It's more something you learn with habit. It's something that you should try and do. If you ever feel you're confused or uncertain about something, be upfront about it. Talk to people. People are there to help. No one in the organization wants you to fail. People want you to succeed, and going to them to help is only asking them for help is only going to help you get to that success point even faster, right? And the reason for this, it's better to ask for help than to provide insights based as a shaky knowledge base. Again, this is specifically for data scientists. You'd rather say nothing than say something based as an assumption that is may or may not be true. Another thing to do is to always talk to as many people from as many different fields as possible. Being a data scientist, it really helps if if you talk to someone who's in your engineering or your backend teams or your data ingestion teams, to sort of understand what all they do to make your product successful, and that helps you sort of be empathetic towards their concerns, their timelines. If you're trying to propose something and your backend dev is saying, no, I don't think we should do it this way, because doing this could slow down system performance by 2-3%. Thinking about these things, thinking about the entire end-to-end pipeline, full stack in the engineering sense applies to the data science sense also, because we are also part of the stack. We are building products that go from front end to the back end and back. So talking to other people, understanding how these systems work and all is really really helpful for your own personal growth as well, and really adds value to you as a data scientist, being able to like, foresee like, engineering changes, forcing data set changes and whatnot. My last couple of advice points are, more high level, like, like I touched upon before, don't overthink experimental failures. It happens to everyone. Like I said, any data scientist will tell you that 90% of the experiments they run are inconclusive or unsuccessful, but doesn't mean that they're a waste of time. Failed experiments are just as informative as successful experiments, and knowing what to not chase after is also super valuable, like especially when time and resources are constrained. And the last one is something I really want to like, I really want to focus and emphasize on is, don't always jump to machine learning as a solution immediately, right? Like stuff like AI, ML, neural networks, recurring neural networks, chat GPT and all, like these are all things that sound really cool. And like, I can see why people are attracted to the field because of these, cool sounding things, neural networks, it sounds amazing. But, proposing these as solutions to like problems is not, as the first solution to problems is not always the right thing. ML solutions take up a lot of time and effort that the organization might not always have or be willing to like invest in. Deploying custom machine learning solutions, are tech heavy and feature engineering at low latency scales requires a really mature data platform. Again, not every organization has it. At Rapido, we ourselves are like, getting to a point, where we can, serve like a bunch of machine learning models at like really like low latencies in production, because it's a challenge, like just building a, like Kaggle may give you like these really great features, data sets with like columns and features already made, but when you need it real time, you need like a really mature to like compute all that and like serve it to your data application like in like a millisecond latency. So machine learning should only be considered as a solution when you feel like you've reached the ceiling in terms of value add by doing the simple things, right? Like I don't need to do like a complex classification of, okay, show this or show that to this driver real time, when I know that I still have like 20 different things to try in terms of, understanding his preferences, understanding his earnings preferences or whatnot, before I go and tell my organization, what, I want to do this through machine learning and please support me on this. And sort of coming from this as well as, like machine learning models are, the way they are designed, they're pretty black box. All like, it's easy to do like a dot train dot fit in a notebook, but then trying to understand like why actually your machine learning model is adding value is non-trivial. Like you have to sit and understand every single feature that went into your model, understand why it's important to your target variable, understand like in what conditions is your machine learning model working well, is it not working well. And from a business point of view, no one likes to have a black box of a product. Everyone wants to know why certain things are happening. Like, because if you go and say, like, I think my business is growing because I have like a gradient boosting classifier, like they'll be like, okay, so what? Like, what is that actually doing for you? Like, where is it adding value? In terms of, black boxes, a lot can go wrong if you don't understand what it's doing, or like in what conditions it fails or what conditions it succeeds. It's very easy for you to like, have like a outage in production or have like a big dip in your metrics just because you didn't spend the time to sort of understand what the machine learning model does. And it takes time. I'm not saying it's something that you can easily do, which is why like, this is my like, main point for aspiring data scientists is like, don't think of data science as ML as a service. Like, your job is to add value using insights and data. And sure, like, there will be times where you have to use machine learning as a solution, but don't ever propose it as the first solution. That is my like number one advice for aspiring data scientists. And when you have people coming into a certain field and you're interviewing for jobs in data science, like, you should never go in thinking, like, I'm going to just come and start building machine learning models, because yeah, that mentality is never helpful.
Right. No, that is actually very helpful, because This is one of the most common questions we get. Okay, when will I start to do machine learning? But the idea is that you have to add value through the insights that you can derive from the data. And machine learning is one tool in this huge tool belt. It's, of course, it gets all the hype because of all these, everything that's happening in data science. And just having seen things internally, worked in data for over 2.5 years, and having seen also all the advances that are happening in AI over the last 2, 3, 5 years, what do you see as the future of data science, both just globally, but also specifically in India?
Definitely. Like, so as, tech and, internet ready devices such as mobiles and laptops are getting more and more common, specifically in countries like India and like, developing countries, while they are more prevalent in like more mature nations. What that means is like there are more and exponentially more and more data points that are being generated, like for in every field where there is a product, right? Like data driven insight providers are only going to be more and more valuable going forward, as every business at the end of the day like wants to take very informed decisions with their time and their money. And this information is usually coming from data scientists and data teams, and like, your analysis groups trying to, tell you, "Okay, okay, do this, then that, because we have seen, our users are from here and they like to do this and that." And like basis that, you set up your roadmap for how you want to, like grow the business. So data is only going to be more and more important going forward, and knowing how to interpret it and understand it is really key. Like I said, these insights and learnings are like a big part of how like businesses plan and like put in place strategies to like get to the next level in terms of growth. In terms of, like data at scale, like, machine learning, ML engineering, which is something that is sort of up and coming right now as like, you know, a subset of data engineering, is going to become really important as we, progress to like low and no code AI ML deployments. If for a lot of you guys right now, like doing stuff and like building web apps and all is super simple because of a lot of advances that happened in this field over the last 15, 20 years. Like you would have to go from like, actually having a real server room, having a co-located server, to like actually do things at scale, to like a point where you are right now, where like things like Google Cloud and AWS allow you to sort of, build and deploy applications really, really easily. And the same is going to happen with machine learning as well at an enterprise level, where organizations, instead of having to like small and medium scale organizations, instead of having to invest in a really expensive and time consuming like data science and ML engineering team, will be able to use ready to go package solutions right out the door, and sort of use that to start getting value in their own businesses without having like a full end-to-end machine learning pipeline. That being said, larger organizations almost 100% going to continue to have in-house ML engineering and data science teams, because nothing can beat like the flexibility and customization that like your own team can give you to like build a custom solution. Just because you have like something like AWS available right now, there's a lot of things that AWS does not provide you in terms of like auto scaling or capacity or preemptible nodes. If you're doing something critical, you want your own dedicated like cloud instances that no one can take away from you, at no matter what the situation may be. In terms of research and like development of ML algorithms itself, like I said, as more and more people come online and like start being a part of the online ecosystem, and downloading apps and joining social networks and whatnot, machine learning algorithms play like a huge role in like like detecting outliers and frauds. So as your data set scale, detecting outliers becomes just as important as your online user base scales, detecting fraudulent actors and like people who really are trying to abuse the system is going to become more and more important. And ML classification algorithms will become more and more a part of like these large scale data platforms, interconnected data networks and platforms. Another thing is, like as country as online marketplaces and online ecosystems mature, like more and more data privacy regulations will start coming into play, like they already are in the Europe with GDPR, where like certain data anonymization rules are like a must for data applications, whereas in India like rules may be really lax. Like in India you may find like your like a data scientist from a particular organization can probably look at like your entire personal information just by like querying like the master users data set and whatnot. They can probably get your phone number, your email, your address and whatnot. All that is anonymized at Rapido if anyone has any concerns. But yeah, like as data privacy regulations become more and more strict, some of there may be a perception that the value add from data science would go down because you have all this anonymized data. But I mean, anonymized data is still really, really valuable. Data is very crucial in helping scale systems, helping knowing where to invest, where to spend your time, what kind of like sub segments and sampling. Anonymized data is like another place where like machine learning is going to play like a huge part, trying to build like understanding of your users using like random forests and decision trees is still going to like add a lot of value even though you don't know anything about your customer. And yeah, like I said earlier, like software engineering moving towards full stack, like you can expect the same to happen to data scientists as well. Like there will be an expectation to be proficient in DevOps skills such as scripting, logging, cloud tools, as well as some ML engineering experience to help be like a well-rounded person who can not only build but also deploy machine learning models. This, I mean, everyone may have a different opinion on this, whether it's good for the ecosystem or not. But it never hurts to like do this just as a passion. Like, like if you are able to spend some time like learning a new skill that demonstrably impacts like the ability to do your existing job, I don't believe there's any downside to that. So yeah, I think that's sort of the future for data science. I mean, this is my take on it. I'm not sure how much of it will actually be true or not, but yeah, over the next 5-10 years I can see a lot of these things coming into play, at least for day-to-day data scientists.
Great. Well, thanks a lot for sharing that perspective. I think that makes a lot of sense. It really feels like we're at this inflection point where data science as a whole is kind of permeating every aspect of what a certain product or certain service can do. And we're all, everybody across the board is in the process of figuring out what is the best way to get the most out of this? What is the best way to make it efficient? What is the best way to set up that iterative cycle that I think software development has kind of reached? But how do you merge software and data and continue to do that? And
For sure.
yeah, I think
Yeah.
all of that is definitely something worth looking forward to. All right, well, we're almost on time, so I'm just going to ask you a couple of last questions that I like to ask everybody that we interview. One is, this is a question on everyone's mind. What do you look for when you are interviewing somebody for a data science role?
That's a good question. Almost always I'm looking for someone who has clarity of thought to deal with like a new problem statement. Like there is no like set of questions I'm like making sure that you have to be able to answer. It's not like a lead code based interview where I need you to like be able to like reverse a list in a certain amount of time complexity. No, like most of the technical and statistical stuff you can Google. I don't care if you don't know it right now. I know you can find out later. One of the things we really look for is, okay, if I give you like a new problem statement that we are working on, like how do you think about it? Like, are you able to like within like 1 hour or 1.5 hours, like come to like some semblance of, okay, like this guy or this girl can like figure out like how we think and has figured out at a high level, like the touch points that we care about. and someone who asks a lot of questions. If I give you a problem statement and then you're quiet for 20 minutes, that's not helpful, because I am there as an interviewer to help you out. I'm there to help guide you on that thought process, because that's how data science interviews should be. Like, it should not be like, okay, tell me the difference between bagging and boosting. You can like read about that like once you get the job, but like if I ask you something like, okay, like how do you deal with like customer perception of your app, or like why didn't you think about this when like you said that, like as long as you can give me a reasonable answer, like that's what I'm looking for. Like, obviously having a somewhat of a base in like math and statistic is important. Like, you can't be totally clueless about it, but that's like 5-10% of it. Most of the time it's like, how do you deal with like an abstract problem.
Fair enough. All right. And then the final question, because we are a learning platform, because everybody here is in the process of learning, we'd love to know from your own learning journey, what were some of the best resources that you used, whether it's books, courses, tutorials, whatever it was. What was something that you found really helpful when you were learning some of this stuff?
Honestly, Google, Stack Overflow, Stack Exchange, towards datascience.com. Like,
Right.
straight up, like I feel like there's so much good knowledge available out there, so many great creators, like like people that put up YouTube videos explaining like how even something like a classifier works, how does a decision tree work, like some guys are like gifted at explaining complex problems really simply. So I have no shame in like saying that like most of like what I learned about like being a data scientist has been on the job, like literally not knowing what to do and googling frantically. You like, okay, how do you deal with such a circumstance, like studying. I mean, in college, like no one teaches you like how to deal with this sort of ambiguity. You're learning theory, you're learning, okay, like you learned this, how do I get a good score on the test that comes. You don't have the privilege of having that ambiguity, dealing with others who are also facing the same ambiguity, knowing that there's no right or wrong answers, like knowing it's a process. So like my greatest, yeah, resource has just been like blogs and YouTube videos.
So it looks like you've taken a very top-down approach towards learning some of this stuff, where you jump into a problem, and wherever there is kind of a piece where you feel like I don't have the answer, you go in and you try to maybe learn that piece of theory, or maybe kind of figure out what tools you can use. Is that accurate?
It's accurate to like a large level. Like if once you spend more and more time, like you don't have to like be as top down about it. You can straight away know that, okay, I can solve this in a way in which I know what I need to do. And you try and like minimize, or not minimize, you try and be careful about and set correct expectations for cases where you need to go learn something, or you need to take some more time. You just know that, okay, I don't really know what to do, but give me some time, I'll figure it out, or let's do this together. Like I said, most people that in the community are really happy to share and like help others grow, and hoping I can do the same for others.
Great. All right. Well, thank you so much, Siddharth. I think it was really exciting conversation, and we touched on so many different topics in just 90 minutes. Thank you all for also asking so many insightful questions. And yeah, I think we are going to wrap up here. So any final words to that before we close?
Yeah, I mean, again, thank you guys at Jovian so much for giving me this platform to just have this informal conversation with you and like the rest of the folks on the call. And yeah, really happy to talk about like my journey, and hopefully talk about some of the things as a data scientist that are not as commonly talked about in like most lives of data scientists. Like everyone thinks we do like all this cutting edge cool stuff all the time, but that's not the case. Like there is a lot more to it. I would say all the cool stuff is only like 10-15% of it. And this is something that people need to know. You don't want to go into a field thinking, okay, I'm going to be doing this, and then be disappointed when you realize that you have to do a lot. You have to do not just that, but you have to also think about all these other things. You You have to think about the larger picture. You have to think about, like, the resources available at hand. And yeah, and I'm glad that so many people like joined in from all over the world, and hope I could have added some value to your day.
Absolutely. And just once again want to say that it's amazing the kind of work that you and the entire team at Rapido is doing. And thank you so much for taking out the time for putting together this case study and for sharing everything in so much depth. Thank you. And
Thank you so
we hope
much,
to have you
guys.
again sometime. Yeah.
Yeah, I would be thrilled. Thank you so much. And yeah, hope everyone has a really nice weekend up ahead.
Great. Thank you all for joining. And I just want to add that we have dropped a link to a WhatsApp community that you can join. So we have, in case you want to interact with others on the call, in case you also want to get in touch with us, want to talk about career and stuff. Of course, we have a lot of things around that. So please do check out our WhatsApp community. We will have a recording of this session for you as well. And with that, we will sign off. So thank you and
All
have a
right.
good day or good night.
Bye bye. Good night. Take care.
Bye-bye.